Hello friends, so let us go ahead with this stereochemistry. In stereochemistry, we are going to start with the next point, that is nothing but the chirality. So when we are learning stereochemistry, at that time we must understand some basic concepts in stereochemistry, and in that the first basic concept is the chirality. So what exactly the chirality, what exactly the chiral center, what is exactly the achiral center in many organic compounds. So let us try to understand this concept. The chiral center is nothing but the carbon atom with 4 different groups attached to it are known as chiral carbon atom. Let us try to understand this concept. Whenever we talk about any carbon atom, now let us consider this carbon atom. On this carbon atom we have NH2, we have OH, CH3 and hydrogen. All these 4 groups are different. So now you can see here, this is OH, then we have NH2, second one, third one is CH3 and the hydrogen atom. So all these 4 groups are different. Such type of carbon is known as chiral carbon atom. Chiral carbon atom. This is very important. This is also known as asymmetric carbon atom. So both the names are there, asymmetric carbon atom or chiral carbon atom. Both the names are correct. Such carbon atom will always be sp3 hybridized atom. So always remember this thing, because on carbon atom when 4 different groups are present, then automatically it should be sp3 hybridized atom. Presence of chiral center in molecule always results 2 isomers. So whenever chiral center is there, at that time please note that always it should contain the 2 isomerism. Now let us take this second example over here. Now you can see that the first group is the OH group, second one is NH2, third one is CH3 and again the fourth one but same group, so I have written as a 3. So instead this is 4th but this is similar to CH3. So here what happens, OH and NH2 are different, again CH3 is different, but these 2 groups are similar. But according to our definition of chirality or the chiral carbon atom, 4 different groups should be different. 4 groups should be different. This is the minimum requirement for this chiral carbon atom. Now let us take another example over here. So you can see here, this is OH, CH3, NH2, H. So we have chiral carbon atom. So I can mark like this as a chiral carbon atom or like that. And here you can see that this CH3 and CH3 are same. That's why this carbon atom is a chiral carbon atom. Similarly, let us take another example. Now here you can see that we have this carbon atom and on this carbon chlorine, fluorine, bromine and hydrogen is present. So we have 4 different types of the atoms, and this is exactly how the mirror image to the another one. So you can see here that chlorine is close to this mirror image, fluorine, then hydrogen and the bromine. So both these are chiral, and because of this chirality we have 2 different isomers exist in this molecule. In fact, we have one formula for calculation of the isomerism in such type of compounds. Now here, if you see this compound, this is carbon and 4 different groups are attached: chlorine, fluorine, bromine and hydrogen. So we have one chiral center. This is one chiral center. One chiral center. Then sometimes you may feel that how many isomerisms may exist in this compound. So for that purpose we have formula that total stereoisomerism is equal to 2 raised to n. Here n represent the number of chiral centers. Number of chiral centers. So in this compound total number of chiral center is 1. Therefore if we put this n is equal to 1, so this will be 2 raised to 1 is equal to 2. It indicates that this compound contain 2 stereoisomers. If n is equal to 2, what happens? Then total stereoisomers is equal to 2 raised to n. N is 2. So 2 raised to 2 is nothing but 4. So in such type of compounds, we have 4 stereoisomers.